All right. Hello, everyone. I'm from Singapore Management University. And this is my work, the work of my students who got visa issues. So I'm here to present this work. So basically, as we know, search and the recommendation systems are really everywhere. So basically, all the items from like social media to like search engines to restaurant booking and online shopping, all these items are actually ranked by search engines or recommendation systems or millions or billions of information items. And essentially, we are interacting with those search systems and the recommendation systems every day or even every hour. And these systems help to tackle the information overload problem for us. And then we just take a very quick look over the systems. So a typical search system, right? We have an information need, and then we formulate a query, and then the query put into the search engine ranking for us, right? So this is a typical search system. Whenever we want to find something, we need to formulate the query. If the query doesn't work, then we need to reformulate it, right? Until we success or quit the system. And then a typical recommendation system works in a different way. So basically, the system takes all the kind of user interactions, whether it is clicks, ratings, this kind of thing, and then store in the system. And then based on the system, the recommenders guess the user preference. And then based on the preference, it recommends push the items to us, right, to the user. And then this one also got some issue. Sometimes the guessing might not be correct. Then the recommended items to us might be not wanted by us. And then we summarize. So basically, we can see that a search system, the user usually takes the initiative. We pull things from the system to us, right? And then for the recommenders, the recommender system takes the initiative. Usually we guess the user preference and push things to the user. And then this has the problem, right? From the user side and the system side, usually the kind of requirements is unidirectional and the ambiguities happen and it is unsymmetric. So this is why we need conversation to kind of reach the two, right? So the communication is essential. Right, the search systems what is the good query, and then the recommender system usually struggled with incorrect preference. And then this is why we need interactive conversational recommendation, right? It is in the same kind of information overload world, the user and the system, we have a conversation to link the two. And then we have a very quick review of the current conversational recommendation systems. The initial stage here, mostly it is RL-based. So it's more kind of a sequential recommendation. We always push the item to the user. The user say yes or no, and then we try again, and then again. So usually we interact with the user with the items. So the scenario might be something like this. I recommend the iPhone 10 to you. You like it or not? If not, I recommend you like a Google Pixel 8a. And then I try again, maybe Huawei P40, right? So usually we interact while the items. And then the second stage, those system becomes more kind of flexible. We can let the user to narrow down a bit using some kind of attributes. So for example, now we can say which brand you want. And then what color, right? And then we can say, how about the iPhone 50A, right? So it's more kind of, comparing to this first stage, it's more flexible, but still it's a bit of, how to say, the attributes we need to predefine, the aspect we need to predefine. And then nowadays, the system becomes more flexible. So we can see that the user not only say yes or no, and also can do some kind of chit chat with the system. And then the system can have some kind of policy learning. And here we still got some limitations, of course. Right? Currently, the conversation part and the recommendation part actually are separated. So this is the current situation of those conversational recommendation models. I give you an example here. Right, so this is a typical data, the data we use. So basically, it looks like this. So for example, the user say, good evening, and then the system reply, how can I help you? And then the user can express more information, like, I want some kind of horror movie, creepy, scary, this kind of thing. And then the system can kind of understand and show some kind of like actor or actress or director, this kind of information, and show that there are some good movies like this. Do you interest? And then they can chat more in more kind of freestyle. So basically, we can see that the system have two components. One is the recommendation component, which collects user preference based on some mentioned entities or some kind of indicative words or terms. So this is how they get to know what the user want. And then we also have a response generation component. Well, this response is conditionally generated using some given conversational history, basically something like this. So, however, there exists some kind of data scarcity problem, because currently we do kind of recommendation or response generation only based on the current conversation. So which is kind of a very narrow kind of scope. So there are some works trying to make it more kind of knowledge enriched. So they go to some kind of knowledge graph or customer reviews or even collaborative records. So using those information to enhance the recommendation part. But however, we still say that it's kind of over-exploring those external data, and then they ignore the analogous internal conversations, which means suppose we can imagine there is a conversational bot. We have a lot of conversations. Then why not we make use of some formal conversations to help our current conversation, right? So this is our kind of intuition in this work. So we can see that given the conversation history, which is put in here, a traditional CRS model, I take the input and then I output a response here. And then our scenario is more like, given this conversation history, why not we find some kind of conversation, related conversation scenario or the examples, and then make use of those knowledge in addition to some kind of external knowledge. So we may also make use of those analogous internal conversations and then help us to generate a better answer. So this is the main idea of our work here. Then, of course, to realize this, we have some issues or say challenges to tackle. One thing is how to retrieve those similar demonstrations, right? And then another one is how to leverage. Suppose I can find some, like I can use BM25 or even some kind of other dense retrieval models, right? I can retrieve some kind of similar cases then, but how to use it, right? So this is the two issues we need to tackle in our work. And then looks complicated, but actually the idea behind is simple. I will introduce them one by one. So first of all is the retrieval part, how to retrieve the demonstrations. The idea here, right, as many works showing, external knowledge actually works quite well, right? For example, given a specific movie, suppose we have a knowledge graph. It connects to all the actors, actresses, and some kind of information terms or the directors. Why not, right? Why not use it? So we still make use of those knowledge graph to enhance the entities contained in the conversation. So this part we still keep. While another thing is we also encode the conversation context. And then we make use of the contrastive learning to make the entities fit with the conversation context. And then we encode this with a dense retrieval model. Given the conversation, we retrieve the top K conversations, use as our demonstrations here. Right? We have a matching component. So this is the basic idea behind. And then we do the response generation module. So given those retrieved similar cases, how to use it, right? This is the goal. We want to improve the response generation with the demonstrations. But the challenge is we can do simple concatenation, right? When we have a large language model, we can put all the things into the input. But the problem is it will be too long. Then we do a bit of contextual prompt learning. So how do we do it? Looks kind of difficult, but actually the basic idea is something like this. So given the conversation, context, and response, those like 3 similar cases, we will, which is X, which is the dialogue context, the response is the Y, and then we put some tokens here to put into the as the prompt, go to the frozen Roberta model. It's kind of, we can summarize the things into the prompt output, right? For example, this is the model, and then this PJ goes into this, and then goes to the blue part. So this is the output. We can think of it as a summarization of the example. And then, which is the PJ here. And then the problem is when we do the response generation, which is actually a dialogue GPT, well, in this summarization part, which is a Roberta, so the 2 space is actually different. So we need to do some kind of semantic mapping. So this is how we do the semantic mapping here. So basically, all those examples now becomes shortened, right? So we have 3 examples, these 3 example vectors, right? Concatenated into here. So it's kind of, we do a bit of summarization, mapping to another space, and then still do the concatenation. And then we put into the dialogue GPT, generate the response. So currently, we see the response generation part is still a simple mask, right? Then later, when we do recommendation, we recommend the item, then we put the item into this mask place, and then we finally get a final result. So the recommendation module, how does it work? Still, we have demonstrations. Those demonstrations, we will, however, there are challenges because demonstrations are text, right? While for recommendation, our output is actually a ranking list. So the nature of them is quite different. So how do we do it? We extract the entities from the text, and then still we do a bit of knowledge graph, enhanced representation learning, and then we will feed the thing into here, right? The prompt learning thing here, and then generate the candidate items here. So we see there is some small difference here because here we see it's a dialogue GPT model, which is actually for text generation. So this is why we need to do some kind of pre-training. We need to pre-train this part to make this list of entities to predict to another set of entities, right? So there are some kind of pre-training happened here. All right, so that's all the 3 main components, right? We can think of the response part generate the mask the response, and the recommendation part generates the entity, and then we feed into the mask, and then this is the final response we have for the model. And then the experiments is here. We're working on the 2 data sets. One is Riddell, one is Inspired. And then for item recommendation, we use the common metrics. And then response generation, we have some kind of the normal kind of response matching part. We also have some human evaluation, but we didn't put here. And then those are the results. One thing is the recommendation results. We compare with some traditional recommendation methods and also some existing conversational recommendation methods. So the performance is quite good. More analysis can be found in the paper. Later we show some analysis. And then the generation results here, we generated general pre-trained language models are here. And then we have existing CRS models we compare. Yeah. And then some kind of observations. One thing is the retrieval part. We compare with the BM25, or we try some kind of random examples. Because in prompt learning in NLP, some people also show that whether the example is similar or not actually doesn't matter. Sometimes we just put some random tokens there as prompt. Still, the performance can be improved. we want to show whether this happens in our conversational recommendation scenario. The answer is no. Actually, the performance will decrease. And then, so we see that good examples makes better learner. And this one, if we also try BM25, use only mentioned entities. This one actually is not so good. And the good demonstrations benefits recommendation more than generation. This is as expected. And we have more observation results, but we don't have enough time to show here. Right? Basically, retrieve entities or semantic mapping, these things, or is important. And then concatenation one perform poorly, especially for the recommendation. Right? So basically, that's all. And then for future directions, one thing is, as we see, is separated component. Actually, in the future, we hope that we can have some kind of combined model here. Another thing is target-driven, because currently conversation recommendations is more like the guessing user preference and recommend item to you. Another scenario is, suppose I have an item in the system, target item in the system, and then chat, and then we want to make the user accept this item. This is kind of new scenario. Right, and then that's all for the talk. Thank you. Those are some reference papers.